In this video, we are to find the unbiased minimum variance unbiased estimator for the Bernoulli distribution using the Crammer Rao inequality. If you find this video helpful, you can subscribe to this channel. Solution. The first thing to do is to recall that the Crammer Rao inequality is given as 1 all over n multiplied by the expectation into the differential log of the given function f of x theta all over the theta squared. So this is the Cramer Rao inequality. All we need to do is to find the log, we differentiate, we square, we take the expectation and multiply it by n and compare whatever we get with the Cramer Rao inequality. When we do that, we have succeeded in finding the minimum variance unbiased estimator. First, if f of x theta is given as theta x into 1 minus theta 1 minus x, which is a Bernoulli distribution, the first thing to do, like we have here, is to take the log. Take the log. If we take the log, we have ln f of x theta, which is equal to, if we take the log of this, we have x ln theta. If we take the log of this, we have plus 1 minus x ln 1 minus theta. So we succeeded in taking the log. The next thing to do is to take the derivative with respect to theta. So we say differentiate with respect to theta. If we differentiate with respect to theta, we get differential ln of our function with respect to theta to be equal to, if we differentiate this, we get x all over theta. That means with respect to theta. If we differentiate this function, we get plus 1 minus x all over 1 minus theta multiplied by minus 1, because we are differentiating with respect to theta. So we differentiate this function inside. So we get this. Writing it out properly, we have x all over theta minus 1 minus x all over 1 minus theta. So from quadratic equation, the next thing to do is to find the LCM and we multiply this. So rearranging this to have x into 1 minus theta minus 1 minus x multiplied by theta all over theta 1 minus theta, which is the LCM. So we have the whole of this as this. The next thing to do is to expand this bracket. To open this bracket, we open this bracket and see if there's anything we can cancel. So we move over to this other side of the board. If you find this video helpful, you need to subscribe to this channel. So we have it as the mean of our function all over the theta is equal to, if we open that bracket, we have x minus theta x minus theta plus theta x all over theta into 1 minus theta. So of course, this will cancel this and we'll be left with x minus theta all over theta into 1 minus theta. So this is what we'll be left with. The next thing to do is to impute our expectation. So we have n expectation differential log of our given PDF squared, which is equal to, now we are imputing this square here. So if we square the whole of this, we have x minus theta all over theta into 1 minus theta all squared. So if we do this, the next thing to do is to also impute our expectation. We can impute our expectation. So if we impute our expectation will go into this to give us the expectation of, say, x minus theta squared all over theta squared into 1 minus theta. Yes, so this is what we get. Of course, for we to resolve this, we still move over to this other side of the board because the whole of this means something. It means something. So the next thing to do is to write out our function. We have this to be the expected value of x minus theta squared all over theta squared into 1 minus theta. And we know squared. We know that this is our variance of x. We know that the whole of this is our variance of x all over theta squared into 1 minus theta raised to the power of 2. So we have to recall that our variance of x is also equal to theta into 1 minus theta. So if we impute this in place of this, we get something like n into the mean of our function all over the theta squared to be equal to, now we have this here, we have it as, if we have the variance of x all over theta squared into 1 minus theta all squared is the same thing as theta into 1 minus theta all over theta squared into 1 minus theta squared. Of course, this will cancel this, so we'll be left with just n expectation of our mean function all over the theta all squared into, now we bring this, what is remaining? We just have 1 all over theta into 1 minus theta. Now, we are multiplying also with our n. We multiply with our n. So the next thing to do is just to put our n value here. This n will now be n multiplied by this. So we'll move over to this other side. This can give us n into theta 1 minus theta. So this is what we get as our n. Now the next thing to do is to compare with the Cramer-Rao inequality. Since we have gotten this to be the whole of this, so we compare with our Cramer-Rao inequality to take the inverse of this, and it becomes our minimum variance unbiased estimator. So we move over to this side to compare it with our Cramer-Rao inequality. Now we say comparing with our Cramer-Rao inequality, we have our Cramer-Rao inequality to be 1 all over n multiplied by the expectation of our differential log of our given PDF or our given function all over the theta squared to be equal to, now we have n all over this. If we take the inverse of this, for we to take the inverse of this to put here, we now have theta into 1 minus theta all over n. So this becomes the minimum variance unbiased estimator for the Bernoulli distribution using the Cramer-Rao inequality. So this is how we can obtain the minimum variance unbiased estimator for the Bernoulli distribution. For more on this topic, you need to subscribe to this channel.